and record. All right. Well, welcome to a new week. So what I want to go through today is, first of all, the midterm. So midterms are graded, there's feedback posted. So I want to go through each of the questions there and just kind of talk about some of the general issues and look at the kind of thing that you could have done to get full credit. So I'm gonna go through the midterm. I want to talk about any PA3 questions, talk about a set of new ODPs that have been posted, and then I want to go back to developing more concepts in Bash. But let's start. If there's any questions anyone wants to go over up front, let's talk about that. All right, well, let me pull up the midterm then. So general comments on midterm first. So a number of people totally nailed this and got 90s at least, had at least one perfect score. And so if you did well on the midterm by your assessment, nothing to worry about, you're good to go. The remainder of the course is focusing on Bash and Linux. There'll be some C questions on the final exam, but we're definitely shifting our focus over to Bash and shell scripting and getting better with Linux commands and Linux environment. If you don't feel like your performance was very solid, if you're left with a lot of questions about how to do things in C, how to write code, and so on and so forth, you definitely want to do something to try to get more solid before winter quarter starts, and before the final exam, but especially before winter, because the course in winter, CSE224, is nothing but C. And we're going to kind of hit the ground running and just start building on fundamentals of C and dig into pointers and dynamic memory allocation, and then use those tools to build up this notion of data structures. And it's definitely not a course where you can learn C fundamentals, right? If you don't have those the first week, the course is going to be pretty difficult. So if you got a lower score than you expected or hoped on the midterm, I would use it as kind of a call to arms, right? A reminder that, hey, I should probably be doing more C coding, more exercises. And there's websites available that have lots of drill problems you can work on. But another really good source of small exercises is the daily programming assignments, the ODPs. And it's a pretty strong correlation between people who scored lower on the midterm and people who have not been doing the ODPs. And that's not a surprising correlation, because the ODPs are really designed to give you, a chance to self-assess your understanding as we go through the material. And the idea is, we talk about X today, and then there's an ODP that tests your understanding of X. And then the next class, we're going to talk about Y, which builds on X. And there's an ODP that tests your understanding of Y. And if you're not doing the ODPs, it may be that you don't understand X, and then the lecture on Y is not going to make any sense. And then the next week, you've got an assignment that uses X and Y and Z. And if you don't know X and you don't know Y, we're talking about Z, it's not going to make any sense. So the ODPs really kind of help you keep on track, and they help you assess your understanding as we move forward. The ODPs this week, which we're going to talk about in a little while, are specifically geared towards helping you with PA3. PA3 is a bash assignment. And, you know, you can break it down into pieces. Well, some of those pieces show up as ODP 405 and 6. So if you haven't been doing the ODPs, I strongly recommend going back and working on those, particularly the C ones, since we're done with C assignments for the most part. And you can't assess those, but you can try them. And if they work correctly, right, you should be able to tell that from test code. But you're also welcome now, not so much week 10 or 11, but at this point in the course, you're welcome to send me your code and say, hey, I think this works. How does it look to you? Right. And I can usually eyeball it or run my test cases on it, since the assessment system won't work for those older ODPs. If you want to try writing the code, I can still help you with those. So those are some general comments on the midterm and where we stand with this. Now, if you scored very low on the midterm, it's still possible to pass the course, right? But to do this, you would need to catch up on whatever you might have been missing that, you know, caused issues on the midterm. And you'll want to do very well on the remaining programming assignments, and you'll want to do well on the final exam. And the final exam is cumulative. It'll have a lot of bash scripting. It'll have some C coding on it as well. So it's not too late at this point, but if you scored low, you probably need to make some changes about how you're doing things, and probably start doing more coding throughout the course. Technically, if you look at the ENGRCS policies that are listed in the Canvas page, I think you need a 73% to get a C. And you need to pass the course with a C or better to move on. But in practice, particularly with this course, the grade for a C ends up being lower than 73. It'll probably be somewhere in the 60s. But it's not clear until, you know, the exams are graded and I sort of look at where people are sitting, and then I might make a curving adjustment based on what I see. But I wouldn't worry too much about the percentages. I would worry about how can I get the best possible understanding of the material going forward, and how can I improve my understanding of the past material as much as possible. And again, you know, I can still help you with this. If there's things that aren't making sense, if you tried to get your code for PA2 working and it just did not work, right? We can go through your code one-on-one in office hours and look at what you did and talk about why you did it like that, and what are some other ways that you could do it, or what did you try that didn't work, and could we have fixed that up instead of giving up on that and trying something totally different, and so on. And sometimes, you know, the challenge is I don't even know what I don't understand. I'm just struggling. None of this is making sense to me, right? We can still talk about that, right? You don't need to come in and say, okay, I just need to know this and then I'm good. Sometimes you don't know what you need to know, right? You just know that something's not making sense, or you're feeling lost, or things like that. We can still talk about that, right? And it's getting pretty late in the quarter at this point, but, you know, we can still do this, even though it's week 7. And you've still got, you know, over a month that you could spend doing drill problems, right? Going to websites that have lots of C exercises and working on those, or going back and trying to fix some of your previous assignments, and, you know, showing me your code and saying, I think this should work, but it doesn't. You know, what do I do? And I can help you jump into the code with a debugger, right? Or whatever. And all of these things will help you in 222. and everything in 222 will help you in 223. And the goal is that everything that we're doing here at Clark is going to help you when you transfer to your university. And when you're taking, you know, a systems programming course or a crypto course or whatever, you can lean back on the things that we've been doing here at Clark. All right, so those are our general comments. Let's dig into specifics. So everybody remember to do the honor statement, which is great. This has been a big problem in the past, but everybody included this, so thank you. So question 2 is a function. So it's not a main program, it's just a function, and it's named reader. And it doesn't take any arguments, and it returns an int. And the function should ask the user to enter an integer, so there should be a prompt. Ask the user for a single integer, read that integer, and then return -1 if there's any syntax error, otherwise return the value of the integer. So this is a piece of what you did in PA1 when you were writing the sticks game in C. You were asking the user, you know, how many sticks do you want to play with, or how many sticks do you want to take? And we had to know, did they give me exactly an integer? And we had ODPs with this, we had PA1 with this, and the procedure is always the same. So integer reader. So we're going to have to use fgets to get information from the user. Now I asked you to prompt the user. A lot of people didn't prompt. I decided not to take off points for that. But, you know, ideally, we say something like enter an integer. And then to read inputs from the user, we use fgets. So what does fgets take? It takes the name of a string, the length of the string, and where we want to read from. And if I'm going to do a string called str, and I'm going to tell fgets there's 100 characters, I need to declare str to be a string with at least 100 characters allocated. So this will ask the user to enter an integer. It'll wait for them to type something and hit enter. And then to convert it to an integer, we have to use scanf. So scanf takes the string containing the characters we want to convert, and then it takes a format. So we at least need a %d that says I'm looking for an integer. But the thing we drilled on for PA1 and the ODPs was to do a %d followed by a %s. Scan the integer into, you know, an integer variable, so do an int num, and scan the %s into just a character array like this. And so the idea was, you know, if the user types in exactly an integer into str, then the %d will match that integer. It'll get converted into an integer and store it in num. And if there's nothing extra after that, if there's no haha or a 0.3 or a space followed by another number, in other words, if it's a legal integer, there won't be anything left to match this %s. Nothing gets stored in extra, and the scan function returns a 1. So if it returns a 1, that's good. It means the user entered an integer and nothing else. If they typed an integer followed by, you know, haha, for example, then this function will return a 2, because the 12 will go into num and the haha will go into extra. And so 2 is bad. If the user types just haha, that will not match the %d. Scanf won't convert anything. This will return a 0. If this string happened to be empty, scanf does something special. It returns a -1. So out of all of these possibilities, this is the only one which means, hey, we got an exact integer and nothing else. So let's save the value from scanf into an integer. And now we can say if the return value from scanf equals 1, We know we got a valid integer. It's in num. Let's just return that. And you can do curly brackets here if we like. If the return value was anything other than 1, there was some sort of syntax error. Let's return -1. And that's our code, which says, hey, there was an error.
So quick question.
Yeah.
So what about the new line character that you'd get from fgets? Wouldn't that be saved into ampersand string or the percent string, sorry?
No, because scanf by default ignores white space. It treats it as a separator. So
Oh, okay, I
the
got
same
confused
thing
now.
as typing 12 followed by a bunch of spaces. That'll parse correctly. And so some people have used a %C, and the problem with %C is %C will pick up that new line, and it would look like you had two things on here. But %S says, you know, let's skip over any spaces, new lines, etc., and then see if there's a string. So it would pick up that and that and that and so on. And it's a little bit of a goofy thing to do, but it works well. And like I say, we drilled with this in a number of different exercises, and it's a pretty reasonable way to parse an integer. All right, so that or some version of that would work well for question 2. And some of the issues I saw in there was you know, not using scanf at all, using scanf with just a %D, not doing an fgets. And you know, if you don't do an fgets, then you have nothing to scan to convert to an integer. Some people tried to use argc argv, but they didn't declare argc argv anywhere. There's nothing to connect what the user is typing to argc or argv, right? Here I'm very clearly, you know, waiting for the user to type something, hit enter, and then saying store what they typed into this variable. Some people got through this but didn't return anything at the end. Some people printed the integer instead of returning it, right? And the specification is, right, it should get an integer from the user and then return either -1 or the value of the integer. So it's a function, it returns an int. So yeah, basically fgets is input, scanf is parsing. That's a perfect way to think about it. All right, so question 3. This was a function that takes an integer and returns an integer. And so the function is called extreme. Takes a single argument. If the argument's less than 5 or larger than 5, it returns 100. Less than 5, it returns -100. 5, it should return 0. And there's some examples. So this is mostly an exercise in knowing how to put together a function. So integer extreme, and you know, you have to give a name to the argument so that you can use it inside the code. When we prototype, we just specify usually the type of argument, although you can also put in a name here. So in PA2, we prototype, we put names in. In the ODPs, we haven't, we've just prototyped like this. But when you write a function, right, we can't do anything with the argument if we just say int. That won't compile. We got to give it a name so we can use it. And then the behavior is if the argument is less than 5, we should return 100. Sorry, greater than 5. I keep switching that. If the argument is less than 5, then we should return -100. Otherwise, we should return 0. And so that would work. And there's lots of other ways to do this that'll do the same thing. So I could use else's. Else if num is less than 5, else return 0. Else's aren't necessary though if the previous statement's going to return, because if num is bigger than 5, I'm going to exit my function right here. I'm never going to get down to this line of code. So the only way I'm going to get here is if this if statement failed. And that's really what an else is saying. It's saying if this statement fails, then I want to do this. Well, that's going to happen. If this statement succeeds, I won't execute this statement because I'm going to return. And same thing here. And when I get down here, what do I know? I know my number is not bigger than 5. I know it's not less than 5. It must be equal to 5. But I could be more explicit. I could say if number equals 5, return 0. And that does exactly the same thing. And some people made an integer. And if num was bigger than 5, set that integer to 100. If it's less than 5, set it to negative 100. If it's equal to 5, set it to 0. And then they said return that integer. And that works perfectly well too. So there's lots of different ways that you could write this. But that's the desired behavior. And so issues I saw here again, some people printed these numbers instead of returning them, right? If you use the square root function and it printed the square root of your argument instead of returning it, it would not be as useful, because maybe you want to take that square root and save it in a variable. Well, if the function is printing it, you can't get that value. So most functions will return things. So definitely pay special attention to how the function is supposed to act. Should it be printing something or returning something? And in this case, we wanted it to return something. Not using an argument up here. Some people used fgets to ask the user while this function was running to type in a number. And you can do that, right? That's what we were doing in the previous function. But in this function, it doesn't say, stop the program and wait for the user to type something and enter. It doesn't say, ask the user to enter a number. It's a function in kind of the mathematical sense. It takes in an integer, it returns an integer. So no fgets, no scanf, no argc, no argv, and so on. That's probably the main things I saw there. All right, question 4. So question 4, we're writing a main program. So you're gonna have to have a void main or an int main. And we're dealing with command line arguments. So remember week 1, we talked about command line arguments versus runtime inputs. So runtime inputs, your program is running and it's waiting for you to type in some input. Command line arguments, you specify information before the program starts running. I type some hello world and I hit enter, right? Once I hit enter, my program starts running and it picks up, this argument from the command line and this argument from the command line. So here we're dealing with command line arguments, which means we want a main program that can access those. And so the usual way is int argc char ** argv. And so this one I did get particular about syntax, because we really need to know this pair. This has to be an int, this has to be a char ***, or char * argv bracket bracket. That's the notation I never use in class, but some people use it, and that's totally legal. But this has got to be a char ***. It can't be an int, right? Even if we want our arguments to be integers, it's got to be a char ***. And so inside our program now, we can get to the command line arguments. So if the person says something like, some hello bye, what does this mean? Well, argc will be equal to 3. Why? Because there's 1, 2, 3 things that the person typed. This will be an array of 3 elements then, argv. Argv0 will be the first thing the user typed, sum. Argv1 will be the second thing the user typed, hello. And argv2 will be the third thing the user typed, bye. So with argc and argv, we can get to all the information we need here. We can get to, in particular, these command line arguments. All right, so how do we find those? We don't want to use argv0 because that's the name of the program. What we want to do is we want to pick up this thing and this thing. So let's go from I equals 1. And the usual drill with arrays that are indexed starting from 0, if the array contains 3 things, the last element is indexed 3 minus 1. So we want to take I up to argc minus 1. And the way I've been doing that in class is to say I less than argc, I plus plus. And so what we want to do is add the length of the ith argument, which is argv bracket I, to a running sum. So we can say sum equals sum plus string length of argv bracket I. So sum has to be initialized. It's an integer. Set it to 0. And so in this use case, for example, we'll start off with I equal to 1. We'll add the length of argv bracket 1, that's hello. So sum will be equal to 5. And then I will increment to 2, that's still less than argc, which is 3. We'll add the length of argv bracket 2, which is bye. So we'll add another 3 to sum, so sum will be 8. And then I increments to 3. 3 is not less than argc, so we'll exit the loop. And then in this case, we're printing the sum at the end. So now we can say printf %d \n sum. And so that would do what we need. And says if there's no arguments, you should just print a 0. Well, our sum is initialized to 0. If there's no arguments, argc will be 1. I is 1, it's not less than 1. This loop will never execute, and we'll just come right down and print out sum, which is a 0. So you don't really need to do a special case for 0, but you can. So inside here, instead of adding string length, we could say something like, you know, integer len equals string length. And then we could add len right here, and that'll work perfectly fine. But if we do something like up here, right, set len equal to string length of something, and we try to use len down here, the value of len is never going to change, right? If we set this equal to string length of argv bracket I, the thing about C in most languages is they are sequential. So this would set sum to 0, and then it would set len equal to some value. And every time I use len, it's going to use that same value that it was set to. So it's not going to actually replace len with a string length of argv bracket, whatever I is right now. It's going to calculate a value for len up here, and that's the value that's going to be used every time that I use len. And this is a little counterintuitive, but it's how most programming languages work, right? This is not saying when I say len, I want to do this. This is saying do this once, set len equal to that. And then every time you use len, use whatever that number is. And it's a little bit of the difference between a variable and a function. So if I used a function down here, like a call to string length, that gets executed at the point where I'm using it. But once I've called a function and saved the value, then I just have that value and that same number gets used every time. Does that make sense? Cool. All right, so issues in here, not doing the integer and the car star correctly. Cool, awesome. Not setting these up correctly. If you were off on the indices, I only took off 1 point because that's just something that is hard to remember and hard to keep straight. But you write some test code and try it out. So, you know, is argc 3 or is it 2? Well, it turns out to be 3. In bash, it would turn out to be 2. So I took off a point if those indices weren't, you know, if they were off by 1. Initializing your sum is important. Adding to that sum inside the loop. Making sure you're taking string length of the argument. Not doing any scanfs. There's no need for a scanf in here. We don't need to convert anything. And since argv bracket I is already a string, we just want to use that. And if I scan that with a %s, I actually will probably change the string. Because scanning a string with %s basically says, give me everything up to the first space. And it may truncate our string. But I mean, since this is already a string, we can use it directly in string length and so on. And yeah, so I less than argc is exactly the same as I less than or equal to argc minus 1. So those both work. You definitely need to print the answer at the end. And returning it is something you can do if you declare this to be int, but then it's doing something a little different from what it asked. Let's see. Yeah, so since it says, you know, if there's no arguments, you should print out a 0. You could put this whole thing inside a loop. So if argc is bigger than 1, you could do all of this stuff. Otherwise, print out a 0. Or you could switch that around and say if argc is less than or equal to 1, print out a 0 and return. And then you don't have to put all of this inside, you know, an else statement or inside brackets. But if you wire this up in most ways that'll work, it'll sort of automatically print out a 0 if there's no arguments, because your sum is initialized to 0 and your loop doesn't change that sum. So any of those ways would be good for handling the case where there's no arguments. Welcome. All right, question 5, whiz bang. This is more commonly called fizz buzz, and it's one of the most common coding interview questions, and it's discussed a lot in academia and in industry, because apparently, according to the numbers, something like 90 to 95% of applicants for entry-level coding positions cannot code this question. And it's not a particularly complex program. It basically prints out the numbers here from 0 to 100 with some words next to them. But the question is, how do we get it to put out, these words in the way that's described up here? And that's the challenge of the program. But if you approach it, sort of step by step logically, it turns out to be not a very bad thing to try to do. So the basic deal is if the number that you're printing is divisible by 3, print out whiz. If it's divisible by 4, print out bang. And so if it's divisible by both, you should print out whiz bang. And there are a lot of ways to do this. And sometimes, you know, people try to find the most elegant way, or the way that takes the least amount of code, or the way that uses the fanciest version of a program that they can think of. But, you know, I didn't ask you for any of those. And so we can do this in a pretty straightforward way. So let's do our void main, and we don't need any command line arguments. And on these main programs, you want to include, you know, standard IO, string if you're using string, and so on. But just looking at the program itself, so we're definitely going to print out the numbers from 0 through 100. So we can, you know, I equals 0, I less than or equal to 100, I plus plus. And the first thing we want to do is print out our integer. And so if we think about this, right, if the number is divisible by 3, we should print out the word whiz. Well, that's an if statement. If the number is divisible by 4, we should print out the word bang. That's an if statement. And if we write those two if statements and our number turns out to be divisible by 3 and divisible by 4, well, this first statement would print whiz, the second would print bang, and we'd end up saying whiz bang, which is what we're supposed to do. So I mentioned in here, if you want to know if something is divisible by something else, use this percent operator. For example, if n is divisible by 3, then n% 3 will be 0. So that kind of tells us what we need in our if statement. So something like if n% 3 equals 0, let's print whiz. And then if n% 4 equals 0, let's print bang. And then whether we just printed an integer or we printed whiz or bang or whiz bang, we want to print out a new line. And that's probably all we need. Yeah, I have had, not on this year, but when I've given this in the past, I have had people who they didn't write out all 100 print statements, but they wrote out the first few and said ... And, you know, I mean, that will do what it's asking, just not in the way it's asking. Although in a coding interview, you could actually write a program that generates 101 print statements and then use that to sort of automatically have the machine generate its own code for printing this out. And you might get bonus points in an interview for that. So this will work. But this, I think, is a very sort of straightforward interpretation of the way this is written, right? Print out whiz if the number is divisible by 3. Well, that's what this statement does. Print out bang if the number is divisible by 4. That's what this statement does. But trying to change this into something maybe more elegant or maybe more familiar is where problems start to arise. For example, if I put an else statement here, then this will not print out whiz bang. If I have, sorry, this should be I. For example, if I is equal to 12, well, I% 3 is 0, it's going to print out whiz. If I say else, it's not going to execute this if statement. And it'll print out whiz, but it won't print out whiz bang. Or if I say, you know, if I% 3 do this, if I% 4 do that, else just print out %d. it may not print my numbers except when they're divisible by 3 or 4. And so there's all kinds of things that can trip one up in here. I could say else if %4 print bang, else if %3 is 0 and %4 is 0, print whiz bang. Well, I got to do those in the right order, right? Because if I is equal to 12, this statement's going to be true, and it might not get to that last one. So I could put a statement right in here, which says if I is divisible by 3 and divisible by 4, print out whiz bang. Else if this, print out whiz. Else if this, print out bang. But if I put this statement down at the bottom, that's going to do something different. If I want to know if I is divisible by 3 and divisible by 4, I have to use this. That's the logical AND operator. If I do this, that's the logical OR, and that means something different. I think everybody did the loop correctly as far as starting at 0 and including 100, so that was awesome. Other issues in here. Oh, so some people said if I %3, printf whiz, right? Well, when we say if some expression, this is true if this is non-zero, and it's false if this is 0. So if I %3 is equal to 0, this statement will actually be considered false. So it will not print if your number is divisible by 3. And if I is not divisible by 3, this will be non-zero. It's always going to print whiz. So this actually does the opposite of what we're looking for. And sometimes, we can avoid writing equal, equal, or not equal by just putting an expression in here. But if you're not absolutely positive, and if that's not making things clearer for you, stick with the equal, equal, or the not equal. And be explicit, be a little more verbose. Hey, I want to know if this thing is equal to 0. And leave the shortcuts for later on, when they feel really comfortable. Let's see. Yeah, so let me write this one out because it's worth looking at. Right, so this says if you're divisible by 3, print whiz. If you're 4, print bang. If you're 4 and 3, print whiz bang. Otherwise, just print out the number. And this does not work correctly, right? Because if I equals 12, this is going to be true, and it's not going to do any of these other statements. So if I put this statement first, if it's divisible by 4 and divisible by 3, we'll print out whiz bang. Otherwise, see if it's divisible by 3. If it is, print whiz. Otherwise, see if it's divisible by 4. If it is, print bang. Otherwise, just print the number. So yeah, the order matters in the sense that with if else's, the first statement that's true is the only one that gets executed. So we want the most restrictive condition to come first. And so some people took no chances and coded it like this. So if it's divisible by 4 and divisible by 3, we'll print out whiz bang. If it's divisible by 4 and it's not divisible by 3, then we'll print out bang. If it's not divisible by 4 and it's divisible by 3, then we'll print out whiz. If it's not divisible by 4 and it's not divisible by 3, then we'll just print out the number. And so that's a more explicit way to enumerate your 4 possible cases. And so this is a good problem to play with and think about different ways to write it. And so if you were asked this question in an interview and you did something like this, they might say, okay, could you do the same thing with fewer if statements or with simpler if statements? And it's a good way to find some practice problems to just think about different ways of doing something that you've already done. And you can do this with, your stick program. If you did it with a big while loop with 1 statement inside, can I do it with a while loop with 2 statements inside, or vice versa? Things like that. I don't know if we can make a general rule that we should always put things with ands or ors first. I think it really depends on the particular logic that you're checking in each statement. But you can, maybe not on a test, but when you're writing code or when you're practicing, you can test your code, right? So what I call playing computer, pretend you're a computer. And let's say this is the set of code you're executing. So just think of different values of I and see what your code does. So I said I equal to 3. Well, I%3 is 0. Okay, it's going to do this thing. It's not going to do that. It's not going to do that. And then try I equals 4. It's not going to do this. It's going to do this. They won't do that. And then try I equals 12. And if you're really faithfully reading your code and imagining what the computer will do, it'll jump out at you that this statement is true. So it will do this and will not do that or that. And then you see, oh, wait a minute, I really wanted it to do this. Why didn't it do it? Well, because it's an else statement. And since this was true, it didn't do that. So then you start to think, okay, maybe I should have a different order and so on. But I can't give you a blanket rule, like if you have an and or an or, it should go first. But if you work with this in some sample code and find those spots where it's not doing what you wanted and figure out how to correct it, you'll figure out those rules for yourself. But the way those rules get coded, I mean, that's part of the magic of our brains, right? Somehow our brains will rewire themselves so that when we have to do something like this, it will know how to do it, or, know how to assess what it came up with and say, is this correct or not? All right, so question 6 was a make file. And we were adding a new function, fun2.c. which is called inside the function fun1.c. So fun1 is presumably used inside our main program. And since fun1 calls fun2, fun2 is going to have to be used to build our main program. So this first dependency, index, is going to depend on index.o, fun1.o, but also fun2.o. And if all of those dependencies are available, the recipe is the same, except we add fun2.o to the end. So it links all of those objects together to make the executable. And then we also need to tell it, where do you get fun2.o from? So we add a new target, fun2.o, which depends on fun2.c. Good luck. And then the recipe is gcc-c fun2.c.
So quick question.
Yeah.
So this says that fun2 is called inside the fun1.
Mm-hmm.
So shouldn't it be a part of the fun1 and not a part of the index? Or am I just mixing things up?
So this is pretty subtle. The make file is basically saying, what do we need and what do we have to do to build these different targets? So fun1.o depends on fun1.c. So that's what was in there to begin with. Even though fun1 calls fun2, it does not need to compile fun2 in order to compile fun1. To make this object file, all we need is the source code for fun1 and any header files that it includes. But the whole reason that we prototype fun2 inside here so that it knows, what does this function look like? What's the shape of it? What types of inputs? What types of outputs? But it doesn't actually need the source code. And I could, completely delete fun2.c and I can still compile fun1. The fact that it calls it, that's why we're including fun2.o when we link together fun1 and index. And this is where the fact that fun1 is making a call to fun2, that's where that gets linked in. Those are the filters. But it doesn't actually have to be listed as a dependency, and it does not have to be in this recipe. Does that make sense?
Yes, thank you.
Okay. All right, so that was the make file question. Question 7 was the Seg fault. So why does this program Seg fault? Somebody tell me.
Because you're doing car star S instead of doing like car S and then declaring like how big it's going to be.
Exactly. So the whole difference between those two things so the whole difference between these, they're both pointers, but this one is just a pointer. It's not pointing anywhere in particular though. And if I do this, S is probably equal to 0 because nothing has given it a value. This does 3 things. It declares S to be a pointer to a character. It says I want 100 locations in memory that are available. And then it sets S to the address of that first location. Sorry, my snack just went down the wrong way. And so without this, if we just do this, we can think of S as being null. And when we say F gets, it's going to say, okay, let's take what the user types up to a new line and let's store it in memory starting at this location S. Well, if S is null, it's going to try to store it starting at memory location 0, and location 0 doesn't exist. And so we get the segmentation fault. So the quick fix is to declare S like this, which says, yeah, S is still a pointer, but it's actually pointing to somewhere in memory where there's 100 bytes available. And now when fgets runs, it starts storing the user input at those locations in memory, and you shouldn't get a seg fault. All right, and then the last question was another function. This was the lowdown function, which takes an argument as a string and converts it to lowercase. and I gave you a hint, which was use the to lower function. So this is a function, it's a void. And it takes a car star.
You've got the document covering up.
Yeah, I
Caleb.
was copying. Thanks. So it takes a car star, which I'm just going to call string. And it doesn't return anything, it just converts this argument to be lowercase. And so this was what we did in the read keywords function for PA2. We read a string from the keyword file using fgets, and then we had to convert it to uppercase. And so the to lower function works on a single character. So we can't just to lower the argument. So we need a loop. And the usual way to loop over the characters of a string is start from 0 and go up to the string length -1. So if I say I less than string length, that'll go up to string length -1 and increment. And we can also think of this as an array, and let's just take each character and pass it to lower. And then take that lowercase character, store it back in the string. And so most people did something like this in PA2, except we did to upper instead of to lower. So this question was really taking that same type of logic, that same loop, and putting it into a function. And so issues that I saw here. So to lower does not actually convert its argument to lowercase. It takes an argument, which is a character, it's actually an integer, and returns the lowercase version. So we need to say, string I equals to lower string I, as opposed to just to lower string I. This won't actually convert the argument. Yeah, we could also loop until string bracket I is equal to the null terminator. And so we could do that in a for statement, or we could make a while loop and iterate while string bracket I is not null, not the null terminator. And that'll do the same thing. And that's really what string length does. It loops through until it finds the null terminator. Again, you gotta have a name for your argument so that you can work on it inside your code. Don't want to do fgets, don't want to do scanfs, none of that business. A few people tried to do something like this, hard temp, and they did this. And so this starts off well. It's taking each character from your argument and finding the lowercase character and saving it in this temporary string. And if you went less than or equal to, that would also add the null terminator. But then at the end, they try to do something like this. And that doesn't get you there, right? This does not change the contents of this array. What it's actually doing is, str is a local variable in here. It's saying, hey, let's make this local variable point to temp instead of what it was pointing at before. But that does not change what's actually stored in the areas of memory pointed to by str. So that doesn't work. And you could try doing a string copy, but how do we know that 100 characters is enough? Right? Our input string could be 10,000 characters. And so we don't have a way easily to define how big this temporary array should be. And that's a hint that maybe there's a way that we can do this without having to use a temporary, and that gets you to, well, let's just store back inside the string itself and not bother with those. And that's also something that tripped some people up in PA2. Some people read in keywords and then adjusted it, converted to uppercase and so on, but then tried to do something like this to save it in the array. And that doesn't work, right? Equal signs don't actually copy the characters in this array to the characters in that array. It's really saying, hey, let's change this to point to that array. So that's a PA2 flashback. And I think those were the main things I saw in question 8.
Okay, so quick question again. Sorry.
Go
So
for it.
could you possibly do the string equals temp, but that wouldn't work to actually, that would it be if you wanted to almost create a duplicate of the current string and then return that. So it'd have to be car star low down,
Right.
right? And then you could return that instead. So you'd have the original and then the lowercase version, which is an entire, although I don't know if it'd save it or not because it's anyways.
Yeah, you could
just
do that, but that is an issue that this is a local variable. And once I return, the contents of this could change. So I would need to declare this outside of my function to say, don't reuse this memory once the function exits. Or I could try playing with the keyword static to say, put this in the location of memory that does not get changed. And it starts to get a little weird. And the proper way to do this would be to dynamically allocate memory using a malloc command, and that's a CSE224 topic. That's beyond what we want to have to do here. But you're right, we could do something like that if we wanted to return a car star. All right, any other questions on all of that business?
So I'm back. Hi. So this is, I mean, it's sort of related to the test, but is like, so you said there were online sources available for just random practice code. Does anyone know like a really good, just automatic, just like randomly generates a problem that you try and solve? Like, do you know of anything like that? Or
no, but if you haven't been to the site before, it's probably the same thing, right?
right.
So, and I was looking at this with someone this morning in office hours. So W3 schools is a good starting point. And I point people to this for Java in particular. But they also do C. And like many of these sites, so there's some tutorials you can go through and you can kind of pace yourself if you really understand, you know, the intro and the getting started and the syntax, but you're struggling with data types, right? You can jump down to the tutorials on data types and so on. So there's tutorials, and then there's examples, and example code can be a good way to learn how some of these things work. This was how I learned programming, was by pulling people's programs out of the garbage can, looking at them, typing them in, seeing what they did. So examples can be a good way to learn, but then there's exercises. And so you can go through these and you can go through them in order, or you can jump ahead. So I am not sure on the switch statement. So there's a couple of exercises on the switch statement. And these are kind of fill in the blank questions. So they're a little easier than sort of writing code from nothing. But those can be good. But then let's just Google see practice problems. So W3 resource is good. And this one, I think, gets you a lot more questions. So here's 10 questions on input output, right? And you can try these down here in the editor if you don't want to compile and run yourself, right? You can type them in here. And you can click through to see solutions, but once you see the solution, then you can't do the problem anymore. And when we get into pointers, which will be, in 222, there's 22 exercises that really kind of drill down into pointers. So this is a good site. And there's a bunch of options. So this one looked pretty good too. So what should be the value? True or false, 0 or not? If A is 15, what would be the value of these? And so on and so forth. So these are drill problems. I don't have a lot of experience with any of these, so I can't, like give you like a bona fide recommendation, like, yes, I've used this and it made my teeth whiter and my shirts cleaner. But I've had students use these, especially W3 resource, and they seem to have had good luck with it. So yeah, someone pointed W3 in there. Yeah, you're welcome. So inside here, the thing with return is if I put a return statement inside my loop, like return string bracket I, as soon as a return statement is encountered, that's it, I'm out of the function. So if I put a return statement in my loop, I would set I equal to 0, and I would return, 2 lower string bracket I. It would take the lowercase value of the first character in the string and return that, and I'd exit the function. And a few problems with that. One, it's exiting the first time through the loop. Two, it's not actually changing the string, right? When I return a value, it's saying, hey, if I try to do something with the function value, right? Like if I said, C equals lowdown parentheses string, it would set C equal to the lowercase first character. But also, since we declared this void, yeah, we can't actually return a value. We'll get a compile error saying, hey, you're trying to return a value from a void function. So there's a few issues there, right? We need to do this on each character, and we can't return until we're done. All right, other questions?
So I understand
Cool.
the argument where we're sort of artificially limiting the string, but if we did use a temp variable, technically aren't we still converting it to lowercase, kind of like you asked?
Say that again.
So I used a temp variable like you listed, and I got docked points because I didn't alter the string itself, but isn't that a little bit like, isn't it kind of the same thing, or am I missing something?
So we want to accept a string argument and convert it to lowercase, right? So we're trying to convert that argument to lowercase. I mean, technically, if you convert it to lowercase and store that lowercase somewhere else and don't give it back to the user, yeah, technically you've converted it to lowercase, but the function isn't actually doing anything for the person calling it, right?
Okay, that's fair.
Yeah. It's a little bit of the tree falling in the empty forest thing, maybe. which is a whole nother topic. Yeah, that's the mean C switch. All right, good. Other questions? All right, so let's take a bit of a break. We'll come back in about 5 minutes, and then we'll look at the ODPs, and then we'll start talking more about some bash scripting concepts. So I'll see you back in about 5 minutes. Yeah, you're welcome. All right, welcome back. All right, so let's look at the ODPs. So the current ODP is 405. And this is a bash script. And the script does one of two things. Either it takes a command line argument and prints out twice its value, or if there's no command line argument, it prompts with just a greater than sign, waits for the user to type in a runtime input, and then prints out twice that number. So it takes an optional command line argument. And so I called my script S1. And so if I just say S1 and I put a number on the command line, it prints out twice that number. So if I say S110, it prints out a 20. If I say S145, it prints out a 90. But if I say S1 without a command line argument, it prints a single greater than sign, no spaces, nothing else, just a greater than sign. Waits for me to type in a number. I can type, 5, and it prints out twice that number. And so this should sound, a little bit like the startup for PA3, where we want to figure out how many sticks we're playing the game with. Well, the user can specify it on the command line like this, or they can just type the name of the program stick, and your program will ask them how many sticks they want. So in PA3, you want to say something like, how many sticks would you like to play with? But for the ODP, we've got to be really precise about the format, especially with bash scripts. If I say, enter a number, I'll get 0 out of 10. If I say greater than followed by a space, I'll get 0 out of 10. So we got to be really precise, because the ODP server is just, matching output with what I expect. And so the way we do this is to use this $number argument. And we can say something like, if $number equals 0, that means no argument was given. So now we can print out the prompt, and we can do a read statement to read in how many things they want. Else we can say, number equals $1 and use the command line argument. Or, if $number is equal to 1, then we'll set number equal to $1. Otherwise, print out the prompt and use a read statement. All right. Is this actually on Canvas? That's a good question. If you're comparing to a string 0, then oh, these are not on Canvas. Okay, let me go ahead and put those up there. If you're comparing to a string 0, you could use equal equal. If you're comparing as a number to the value 0, then you want to use -eq. And so why aren't these on Canvas? ODP 404, ODP 405. Oh, because they have crazy due dates. November 2nd, November 4th. Okay. That's 405. Okay, my bad. And this one is due on the 4th and it's available from the 2nd. Okay, so that one's fine. All right, sorry, I had the ODP set up to be due at the end of the month. So Clark doesn't allow me to combine my sections, so sometimes I mess up when I try to do something on both. All right, so you should be able to see 405 now. What would you say if you were comparing the string to 0? So yeah, you could say if bracket, something like that. So I'm indenting, but you don't have to. So leading spaces are generally ignored. Trailing spaces are generally ignored. The spaces in between things, though, are critical. But I'm just indenting because it makes it more readable for me. So you can check $number. If it's a 0, then you want to print out this prompt and then read in a number. Otherwise, just use $1. And there's an important note here. So when you read, you can actually say read-p, which will print out a prompt and then ask the user. So I could say something like read-p greater than number. And it prints out my prompt and I type in, my number, and now my number is stored in there. But if you do this, assess will not give you credit. So do not use the -p switch. Instead, do an echo -n greater than, and then just do a plain old read statement. And that will assess correctly. The problem is when you do the -p to print out a prompt, this does not actually go to standard out. It goes to a different stream called standard error. It's a minor difference when you're looking at the behavior, but for the assess system, it'll trip it up. So print out your prompt like that. That's just an annoyance of assess. All right, so that's ODP 405. And then 406, which is due Friday morning. This is a bash script that you run. It does not type anything. It just waits for you to type in an integer, and then it prints out that many pipes followed by the integer between parentheses. So if I run this, I can type in the number 10. It should print out 10 pipes and then parentheses 10. If I type in the number 1, it prints 1 pipe and then parentheses 1. And this may in some subtle way be useful for PA3, right? Where you're printing your pile of sticks. So use the read statement to read in a number from the user and then make a loop. And loop that many times, and inside your loop, do your echo -n pipe, which will print out a pipe, but leave it sitting on that line. And so if you do this 10 times in a loop, I'll get 10 of these pipes side by side. And then echo. Whatever your variable is called, the value of that inside parentheses, like so. All right, good on the ODPs. All right, so let's go back to talking bash. So we know that $number tells us the number of arguments. $1 will be our first argument. $2 will be our second argument, and so on. So if I run a function and I put a number of words after the name of the function, I can get to those by using $1, $2, and so on. So for example, number of arguments is $number. Argument 1 is $1. Argument 2 is $2. So let's run some test code. So I'm going to change this permission to be 755. You only have to do this once, right? Once I do this, my main program has this execute permission bit turned on. And if I, make some other changes in here and I save it, that bit does not change, right? You only have to do this once after you create the file. You can change the file 1,000 times and it'll stay executable. If I copy this file to something else, I'll have to change the bits on that copy. But you don't have to do this each time that you want to run your program. That would be horribly inconvenient. So we just change this once. So if I run my program and I say this is fun, tells me number of arguments is 3, arg1 is this, arg2 is. So 3 arguments, this is fun. arg1 this, arg2 is. So this is different from C, right? In C, argc would be equal to 4 because C counts this as the first argument, right? Bash doesn't do that. So argc is actually the number of things that you typed after the name of the command. And then arg1 is the first thing that came after, and so on. So I'm rehashing this because I want to introduce a command in Bash that's really useful, not for PA3, probably not for PA4, but maybe for PA5. And that's the command shift. So let me take these 3 lines and put them down here. And I'm going to execute this one statement shift. And what shift is going to do is it's going to basically take these arguments and move them down one spot. It's going to get rid of this, and it's going to change is to be the first argument and fun to be the second argument. And so if I run this again, main, this is fun, it says, the number of args is 3, arg1 is this, arg2 is. After I make the shift statement, now it says the number of arguments is 2. And the first argument is, the second argument is fun. So shift is a way to say, hey, I am done dealing with this first argument. Let's get rid of it. And let's pretend that what the user typed was just the stuff starting with the second argument. And so this can be useful if I want to do something that deals with the arguments one at a time. So let's do this. So let's process our command line arguments inside a loop. So we'll say while $number is not equal to 0, do. Next argument is $1, and then I'll say shift. And this is enough to get me through my entire list of arguments. And each time I go through this loop, my next argument is just $1 because I'm shifting down those arguments. So I'll have to set the permission bits on main2. And if I say main2, this is fun, my loop will run 3 times. First time it says the next argument is this, and then is, and then fun. So we don't have to use this for PA3 or 4, but this may come in useful down the road if you're writing a command or a function that has a bunch of arguments to it, and you want to deal with those arguments one at a time. And it saves us from doing what we would do in C, which is like have some index variable I and try to say $, instead of $1, $2, or $3, use $I for the number of the argument. Well, that's kind of a weird syntax, and that won't really work the way we want. So the shift command is useful, and it just moves everything down one spot. All right, so I wanted to mention that just because it's something that may come up down the road. So questions about that? All right, so next thing to talk about, and I posted something on Canvas. I wrote something up last night and put it on Canvas that we haven't talked about yet. So that's under the bash how to. This thing called bash associative arrays. So this should make more sense after today. But let me just go through this. So the subject here is arrays in bash. And we know what an array is in C, right? For example, if we want an integer array, we can say int and pick the name of the array and specify the dimensions. And then we can talk about the elements of the array like this: data bracket 0, data bracket 1, or maybe data bracket I, where this is an integer variable, or data bracket some expression that evaluates to an integer. And we get to these individual pieces of the data array. So we can do the same thing in bash. And we can just declare an array. We can just start using an array. So for example, I could say, data bracket 0 equals 2. Data bracket 1 equals 3, data bracket 2 equals 5, data bracket 3 equals 7, data bracket 4 equals 11. So I'm making an array of prime numbers here, right? So I've got 5 prime numbers stored in my data array. And if I want to read the value of a variable, I can't just say $data bracket 2, like, echo $data bracket 2. That won't work. So I have to do something a little different. So I have to say echo $curly bracket data bracket 2. That'll get me element 2 of my array, which was a 5. Data bracket 4 inside curly brackets gets me my 11. That's the 4th element of the array. So this is the first thing about arrays. Is, we store them the way we would in C, but to get the value, we have to use these curly brackets. So data bracket, or curly bracket data bracket number. And as long as we do that, we can have an index variable I equals 3, and we can look at data bracket $I, and that gives us data 3. If I said I equal to 1, and I look at data bracket I, that gives me data bracket 1, which was a 3. If I set I equal to 0, that'll give me data bracket 0. Now, if I set I equal to something that, is out of bounds of the array, it doesn't cause any harm. It just gives me back an empty string. And I can store strings in some of these things. So if I echo data bracket 2, now it's equal to hello, even though data bracket 3 is a 7. And really, all of these things are strings. And keep this in mind anytime you're doing bash and working with variables. Most of the things that we have in variables are just strings. And we can sometimes choose to treat them like numbers, but mostly they're just strings of characters.
So you can mix data types in one
So you can
array.
mix data types, sort of, but really they're all just strings. But it looks like we've got, integers and strings mixed together.
Oh, okay.
So we can also do We can do negative indices. And that's kind of cool. But we cannot do fractions or decimals. That'll just throw a syntax error. But we can do something better. So this idea of, let's use a fractional index is interesting. And why would we want a negative index? Well, I don't know, but maybe it would be useful somehow. Why would we want an index of 1.5? I don't know. But let's take this to an extreme, right? So normally we think of data as, a bunch of sequential data. So there's data bracket 0 and data bracket 1. But what if we could do something really bizarre? What if we could actually say something like data bracket hello and use hello as an index into our array? And what if we could do something like data bracket Nick and use Nick as an index into our array? Now that's a kind of silly sounding notion to begin with, but it turns out that's a really powerful and useful thing to be able to do. And so if we want to do this, we have to declare that we're going to use these non-integer indices. So let me get out of here and start over, because once you use an array as a plain old array, you can't do this until you exit and log back in. But I'm going to use a declare statement. I'm going to say declare dash uppercase A data. And that's going to make data a special type of array, which is called an associative array, which is what this canvas entry is about. So you declare an associative array by saying declare dash A. And so we can store stuff the same way. But now we can say data bracket Nick equals, hi again. And data bracket hello equals, greeting. And now I can say echo $ curly bracket data bracket hello. And it tells me the contents of that element in the array is the word greeting. And if I look at the element indexed by Nick, it tells me the data stored there is hi again. And if I look at the index 0, that's just hello, and so on. So this is a plain old array, but we're indexing with things that don't happen to be consecutive integers. In this case, we're indexing with things that are strings. So I don't need the quotes. I like putting quotes around strings whenever possible, but as long as there's no spaces in there, I probably don't need the quotes, but it's just a habit. All right, so this goes by many names. So one person pointed out in chat, these are key value pairs. And so the key is the thing that we're using to access the data in the array. So hello could be a key, and greeting would be the value associated with it. And these are referred to as associative arrays. And they're also referred to as hashes. And so those terms kind of go back and forth with each other. And in 222, we'll spend a good amount of time talking about hashes, and we'll actually implement these in C. And then in 223, we'll use the hash map class to do some work with hashes. But in Bash here in 224, hashes are built into the shell. And by just saying declare -a, we get an associative array or a hash.
So you said that you had to start a whole new session to be able to use that associative array. Is that just because you wanted to use the same name for
That's
it?
just because I use the same name, yeah.
So you could have declared a differently named.
So if I say like var bracket 0 equals 1, and then I try to say, let's declare var to be an associative array, it'll tell me I can't change it from an indexed array to an associative array.
Okay.
And I had already played with data, so, but yeah, you could use a different name also. All right, so why do we want to do this? There's a variety of reasons. So think about some of the things we do when we process information in a program. For example, suppose we're reading in information where we have a name and we have a grade. And we want to store inside the memory of our program a set of names and a set of grades. And then if I type in a name, show me, the grade for this person, I want to see what the grade is. So one way we do this is we make parallel arrays. So we have an array of names. This would be an array of strings. Then we have an array of grades, like an array of integers. And if I say, show me the grade for Nick, I could search this array, take each entry in it, compare it to Nick. And if I find that, element 7 is a Nick, then I could look at element 7 in my grade array and see, that my grade was 75. So we use parallel arrays like that. Or if we like structures, we could make a structure that contained a name and a grade, and then make an array of those structures. So we'd have a single array of this more complex data type. But then again, if we want to find Nick's grade, we search each element in that array for a name that matches Nick. And if we find it, then we read the grade part of that entry and we get the score. But a far simpler way to do this would be to simply make an associative array called grades. And so I could say declare -a grades. And if Nick got a 75, I'll just store a 75 there. And if Phil got an 85, I'll store an 85 there. And if Zog got a 99, we'll store a 99 there. And so I have all this information stored in memory, and now if I want to know Phil's grade, and I'll do this without quotes now, right? I can just look at grades bracket Phil, and there's Phil's grade. And if I want to know Zog's grade, I just index with Zog. And if I want to know Bozog's grade, I index with Bozog and I get something empty, which means there's no grade stored for that person. So I no longer have to search sequentially through a set of data looking for something that matches a key to find the corresponding value. I actually just go into my array with a key and I get a corresponding value back. And yeah, this is pretty cool, and this is really powerful. And this became my big stick when I first learned about these things. Every problem I encountered for the next half a year, I changed into something I could solve using an associative array. It's just a really fun capability. And you can use it in all kinds of contexts. So in PA2, we were tallying how many times we found certain keywords. And we had a somewhat easier task there because we started with a list of keywords and we knew there was no more than 100. But if we wanted to just tally how many times each word occurred, we could make a keyword. Let's declare an associative thing called words. And if we find the word hello, we could just say, you know, words bracket hello equals 1. And if we find the word cool, we could set words bracket cool equal to 1. And then if we find the word hello again, we could check to see if we've seen it. And this says, yeah, we saw it once. And so we could change that 1 to a 2 and store a 2 in here and set words bracket hello equal to 2. And so we could, you know, write a bash script that tallies how many times we see each word by simply using that word as an index into our tally. And so this is like our count array. And how do we know which element to count for hello is? Well, it's stored at index hello. I found the word cool. Where's the count for that stored? Well, it's stored at index cool. So this becomes a really powerful way to store information. And like I say, this does not, you know, affect our next few assignments, but this may be useful in PA5, which will be a more complex program that you get to design yourselves. And so being able to store information like this can be useful. So there's a trick to this. The trick is, so there's examples of all of this, right? So storing and retrieving data using an index, and then non-integer indices, and so on and so forth. And, you know, name equals Zog. So I could echo grades bracket $name, and that's going to give me Zog score. And if name equals Nick, then this will give me Nick's score. So this works like, you know, accessing a regular array. It's just that this doesn't happen to be necessarily an integer. Could be something else. But there's a trick to this, right? The trick comes when we say, okay, I want to look at all the data I have stored in my array. How do we do that? Now, if we have a data array, and we know, for example, that we have 10 elements in that array, well, we just make a for loop, and we can say for I equals 0, I less than 10, let's print out data bracket I. So if we've got a non-associative array, what's called an indexed array, we could look at all the data pretty easily, just loop over all the possible indices and print them out. But with an associative array, the possible indices are unknown, right? If I don't know that I have a grade indexed with the name Nick, how do I know that I should print it out? And I can't, you know, just iterate over every possible index because there's an infinite number of possible indices. So to be able to say something like, okay, I've got an associative array, I have data stored in there. Now I want to look at all the data that I've actually stored. We need to know what all the possible indices are. And so there's a weird looking trick we can use, which is this thing right down here. Dollar curly bracket, exclamation mark, array name, bracket, @. And that's peculiar syntax, but I put it on canvas because of that. If I go echo $, curly bracket, exclamation mark, grades, bracket, @, that gives me a list of indices. And it says, hey, you have data stored at this and this and this. And now if I wanted to actually look at all my data, I could look at the piece of data indexed by Phil and by Zog and by Nick. So here's the last detail. There is a for loop that I am allowing you to use in Bash. It's the for variable in list statement. So I'm not letting you do for loops like for I equals 0, I less than 10, right? You have to use while loops. But this for statement is legal. For variable in, and you can have a list of things separated by spaces. And what this does is it sets variable equal to the first thing in the list, and then it executes the body. And then it sets variable equal to the second thing in the list, executes the body. Sets variable equal to the third thing in the list, executes the body, and so on. And so we can do this to make a for loop like this: for name in $ curly bracket exclamation mark grades bracket @, and then I can say do, and I can say student $name got a grade of $ curly bracket grades bracket $name. And so this expression right here will evaluate to a list of indices. And what I'm doing in the bottom of my loop, so I'm setting name equal to this first piece of the list, which is Phil. And this will say student Phil got a grade of, and it'll print out the value of Phil's grade, right? It'll use Phil as an index into this array and print out the grade. And then when I go back to the loop, this will set name equal to the second thing in this list. So it'll be Zog, and it'll say student Zog got a grade of, and so on. And so this is a useful way to iterate over the elements of an associative array when we don't know what those elements are ahead of time. And so this is all spelled out in this entry on Canvas. So for index in this do, and in this case, index is a variable. It's taking on each of the values from this expression, which is a list of indices. And so in this case, the example stores, elements at index 0, 1, 2, and then an index hello and an index by. And so this for loop shows me the contents of each of those 5 elements.
So just so I'm kind of clear on this, when you're doing the for loop, right? So you're saying for variable in, your data thing, the variable is technically just something new, like we are declaring it right there in the for statement. Is that
Yeah,
correct?
it's just any old variable.
Okay, cool. Thank you.
Yep.
Would you be able to echo name right now, or is it only local to that statement?
Let's see. So that's Nick, which was the last value.
Huh. Okay.
Yeah,
So
kind of cool.
it's not like Java where it's contained in there.
No, it's very, very sort of free and wild. Yeah. So not a lot of rigid scoping, we're not declaring things. I never said that name's going to be a string and so on. So yeah, it's pretty either reckless or free and wild, depending on your perspective. Can be a feature or a bug.
I could just see that getting real confusing with
Oh,
big
yes.
programs.
Yeah. Yeah, so Bash is a really hard language to, for me at least, it's a really hard language to imagine writing super tight code in, code that I can really guarantee I know everything that it's going to do in all cases. But for putting together something quick and dirty, or something that I'm going to use myself and I can fix if it breaks, it's a real joy, because this kind of thing is just so powerful.
And the thing is, I wouldn't know where to start with a syntax, something that checks your syntax to make sure that you're doing what you actually want to do.
Yeah.
But for Bash, I'm not even sure if that'd be possible to check if you're using the right variable or not, because computers just aren't that advanced, In
Yeah,
Java, sometimes it'll be like, are you sure you actually want to do this? I'm like, oh,
right.
No.
So Java will save us from ourselves a lot. It will do a really good job of, if you try to assign one type of variable to a different type of value, it will not let you get into that kind of trouble, and so on. Bash is really kind of the opposite end of the spectrum. I can have a string, I can treat it as an integer, I can do arithmetic on it, and so on and so forth.
Bash does what the name implies. It
Yeah.
smacks things with a big stick.
Yep, exactly. So this kind of thing up here where we're pulling out a set of indices and then looping over them in order to get to each of the pieces of data. That's a particular version of something that we'll call an iterator. And we'll talk more about iterators in 222. And in 223, when we get to Java, there's actually a whole class called an iterator, and it's a particular type of object. But for now, an iterator is basically some piece of machinery or some kind of tool that lets us examine a set of data one piece at a time. And if we have an integer array to go through all of the data, we really just need a for loop. For I equals 0 to 9, let's print out data bracket I, or see if data bracket I has some property, right? We don't really need a special mechanism. But with associative arrays, because we don't know what these possible indices are, we need something a little fancier. And so that's what this is doing for us, giving us a list of valid indices and then looping over each of those indices and then doing something with them one at a time. So that's something we'll call an iterator. And I just mentioned that now because, like I say, in winter, we'll use that term and it'll be related to what we're doing here. So any questions or other comments on that? All right, got some thumbs ups. Cool. So what I want to do on Thursday is address any lingering questions on PA3 or on the ODPs. And then I'm going to go over PA4, and PA4 I posted last night. PA4 you'll have 1 week for, so it'll be due a week from Friday. And it's going to be another game. It's a high-low game, so another bash script. And not really any harder than PA3, just a different type of program. So using what you've done in PA3 should be pretty straightforward to do PA4. And so we'll talk about that, and then we'll just continue digging into more aspects of Linux and shell scripting in Bash. So come by office hours Thursday morning if you have other questions. Otherwise, have a great rest of the day. If you're in 215, I'll see you tomorrow. Otherwise, I will see you on Thursday. All right, thanks everybody.
Thank you.